Yeah,
Ready to go.
yeah, good evening, everyone. This is my first live webinar, so you'll have to excuse me if I don't follow protocol. But anyway, I would like to thank Adam for inviting me to talk tonight. And what I would like to talk about is developing enterprise blockchain applications, something which is close to my heart and that I've essentially been doing over the last couple of years. In fact, I'm going to be using as my case study for this presentation the product I currently work on. But before I get into that, let me see if I can change the slides here. Oops. Bear with me. Hold on one second. I've lost. Yeah, hold on one sec. I'm having trouble with my slides.
So I think
Yeah,
if you just go through it, if you're in that presenter mode, and you just kind of cycle through that, yeah, that should work.
let's try again.
Take two.
Okay, take two.
So now we can see your laptop screen.
But you can't see my presentation. Hold on.
Cannot. There we go. Now we can see it. Yeah.
Okay, now let's see if I can change the slides. Okay, good. Sorry about that. Okay, so let me first of all tell you a little about myself. As Adam mentioned, I'm with EY, or formerly known as Ernst & Young. I'm a blockchain architect and tech lead here in Toronto. And I primarily have two roles. I'm tech lead for a product that we're developing for large organizations and governments called UIUX Challenges Public Financial Management. I know that's a mouthful, but I'll refer to it as PFM as I go through the presentation. And I'm a subject matter resource in financial services consulting, primarily dealing with digital assets and digital asset tokenization. Most of that work, unfortunately, is in the US. So a bit disappointed that Canada isn't adopting as quickly as other countries. But tonight I'm going to focus really on the PFM application and try and give you an overview of some of the challenges of developing a Web3 application. Prior to UI, I was at ChainSafe. I worked on the Ethereum protocol layer for a KYC protocol. I had my own consulting company, and I also was CTO for 4 years and co-founder of an Asian-based internet startup. And I am a career changer. I had a previous career in banking and corporate finance. So what I would like to do tonight is and I'm not trying to give you a marketing overview. I've made the assumption that most people on this call are developers and are interested in the software development aspects. But I'd like to give you an overview of the application, what problems we are trying to solve, a high-level view of the application architecture and the data model that we've abstracted to allow us to solve these problems. Once I've given that overview, we'll talk about some of the unique challenges in developing Web3 applications. Web2 applications can be challenging enough. Web3 adds another layer of complexity, which can have a significant impact on your architecture and the design of the application, as you'll see as we go through this presentation. And then wrap up and some Q&A. Feel free to ask any questions as we go through, but I will have some time at the end for more detailed Q&A. Okay, so let's first of all talk about the tool. PFM is a tool which is used by governments and large organizations to track funding programs. So if you can think of a typical budget from a government, they will allocate funds for various different programs. Some of those are direct dollar allocations. Some of them are loan and grant programs. and then tracking the associated expenditures of those programs and also the outcomes. So that really is the essence of what our tool should be doing. We've been developing this on an ongoing basis since 2019. I in fact, joined the firm just after development had started just over 2.5 years ago. We've completed several POCs and pilots for the City of Toronto, Government of Western Australia, and a large multilateral agency that I'm not allowed to name, but yeah, the interesting thing about these pilots are that they cover a range of use cases. So City of Toronto, the use case was about tracking assets, specifically in the transportation division, and another division, we were tracking expenditures related to their assets. Government of Western Australia use case was tracking maintenance expenditures spent in schools across the state of Western Australia. And for the large multilateral agency, we primarily were looking at a use case where we were tracking loans and grants. And as I've indicated here, we're hoping we won. There was a competition that IMF put on, I think about a year ago, called the IMF Anti-Corruption Challenge. And we were one of the winners of that competition, and we'll soon be going into a production pilot with the IMF and various entities and the government of Guinea-Bissau in Africa. This particular use case is tracking salary, wage expenditures, and employee hiring. So, okay, so let me try and give you some overview of the problem we're trying to solve and some context. So this, oops, lost that. This particular schematic details the typical hierarchy you would see in a budgeting type of situation, and doesn't matter what level of government, most of them would follow this same type of hierarchy. At the top, you have a central budget authority that is responsible for allocating loans and grants and funds to various ministries and departments down the chain. Those entities, in turn, will be on allocating loans, grants, dollars, etc., to various regional authorities to execute their programs. And those entities, in turn, will be expending money with delivery agents to achieve the objectives of those programs. So each of these programs would have objectives associated with them. One of the big challenges that you see here, whether this is a large government or a city government, or even a large organization, one of the big challenges is most of these entities are using very different IT and ERP systems, and it becomes very difficult to actually track where, from anywhere in the hierarchy, where your money is actually being spent, getting visibility on how your money is being spent, and also getting visibility on those outcomes. And the reason it's difficult is because you know, each of these entities may have their own IT system. Some of them may be using spreadsheets, and to reconcile and actually get a picture of what's been spent and what the outcomes are can take many months in some of these organizations, as we've seen in some of the pilots that we've executed today. Let me go continue on that. So, you know, in a nutshell, the current state, if you look at the government, is basically just what I indicated, is you have your central finance funneling money and grants and loans down the chain. And again, each has their own system that they're keeping track of that. And there's a significant amount, as I just indicated, of overhead in reconciling the expenditures and outcomes for those programs. So where the blockchain comes in, it's this green line at the bottom here, is our blockchain essentially becomes the single source of truth for the expenditure of money by all these various divisions and departments. And while this isn't a real-time, it can be a near real-time, because each of the entities in the hierarchy will now have access to the blockchain, plus some of the off-chain metadata that we use. I'll talk about that, and can get a lot quicker, as I say, in almost near real time, a picture of what money is being spent and what it's being spent on. So that leads, that solves the problem of, impaired decision making, and the difficulty of reconciling financial data. It allows us to more easily track the outcomes against the money being spent, because the money is now visible, a lot more visible than it was before. And it also removes transparency, along the hierarchy. So, someone sitting at the top of the hierarchy gets to see how their funding is being used with a lot quicker turnaround. Okay, so let me move on. So before we get into some of the challenges, this is a high-level sort of overview of the architecture of our application. And let me go through some of the key points there. Most of the data most of the data in our system comes through what we call an ingester service, which is responsible for the ERP integration. We also have in that service a file drop zone, where you can drop CSVs, and basically ingester service maps those ERP attributes to the attributes that we require in our system, and sends the files for processing down to our Kafka bus, which is in the middle here, and is the main message bus we use for communicating between our microservices and handling blockchain transactions. We have a background job processor. We do provide a UI. This UI, we call it a white label UI. It's very highly configurable. Again, because there are different use cases, not everyone needs to sort of see the same or have access to the same modules. We have a GraphQL services, which I guess renders data from our off-chain DB and our blockchain. And we have a transaction manager which handles the processing of transactions. We have an external authentication service, and OAuth. Right now we're using Auth0, but that is easily switchable for any OAuth compatible type of service. And then in terms of blockchain, the product is currently configured to run on Go Ethereum on a private permission blockchain. But we are currently in the process of readying the app to operate on public Ethereum and Polygon network. So that's in process. And again, I'm trying to keep this relatively high level, but in terms of the sort of core data model that we've abstracted to achieve and solve the problem, we basically have, this is, I guess, a simplistic representation of this model. We have our entities, which can be a division, it can be, a legal entity. They may be in a hierarchy as designated by this line here. Those entities will have fundings, potentially many fundings allocated to them of different types, loan, grant, or dollars. And again, those fundings may be related in a hierarchical fashion, so down the hierarchy. Each funding has an associated account, and then our fundings, our fundings, we can attach multiple OKRs. This is for measuring the outcomes. So for each type of funding, we have a very configurable and flexible interface that allows you to assign a wide range of objective key results to the funding programs, and facilitates reporting and verifying those objectives through various means and transactions. Sorry, guys. In terms of transactions, these are our static concepts. There's really 3 different ways that transactions can occur. Purchase orders can be opened up, and invoices created or paid, funding requests can be made to draw down the funds, or direct expenses can be made. These would be expenses that may not be associated with a purchase order. So, for example, for City of Toronto, we were tracking the fuel expenses, which weren't subject to purchase order requirements as a direct expense. The other thing to point out is the entities we can track all the assets owned by the different entities, and then we have a very granular permissioning system where essentially all the users in that hierarchy that I just showed could have access to the system, but the permissions and the transactions that they can execute both on the blockchain and view permissions are set at a very granular level, so that we don't violate privacy, and people are only seeing what they should be able to see. So in a nutshell, and again, this is high level, what we do is with our hierarchy that we've abstracted onto both the blockchain and off-chain DB, we get, I guess, a representation of that hierarchy on the blockchain. So, each of these entities will have a smart contract address, likewise with the funding programs and the accounts, and the OKRs as well. And then we can implement permissioning, and our permissioning is implemented on the actual blockchain. So you're not reliant on a DB, using a directory design pattern. So, for each of these, as I indicated, there are, multiple permissions that could be assigned and customized in the system. We then basically track the real transactions that are happening by minting NFT and ERC7 NFT, which are ERC 721s, minting those into the various funding programs. We call those commitment tokens. And when funding is required or expenditures are required to be made, subject to the terms and provisions of those commitment tokens, they can be redeemed in exchange for currency tokens when funding is required. All of these the token movements and transactions occurring within the various smart contracts for OKRs, our invoices and accounts, emit events, and essentially our Kafka bus tracks those events and is able to build up a real-time representation of the funding flows as they occur. Oops, sorry guys. So the event listener basically abstracts all the events and allows us to reconcile, account balances, funding balances, the movement of funds throughout. It also, as entities are added to the implementation, which can be done dynamically, we can events are emitted, and we store for each entity. We store some of the data, the metadata, and typically this is data that would be subject to privacy laws or privacy provisions. We store those in the off-chain DB, Combined with the transactions on the blockchain, we're able to give a near real-time picture of what's happening. So let me turn now to some of the unique challenges. Really, these cover, these 5 areas specific to this application. So the first is UI/UX. The other is the fact that blockchain transactions need to happen synchronously. Otherwise, you could, find many dependent transactions failing. The other issue that is very important is privacy. Gas costs, because we do use an EVM compatible blockchain. And the other thing I indicated in terms of from a design perspective is we need our application to be configurable for a wide variety of divergent use cases and also languages. In fact, we already have a Japanese translation and French translation available. So let me talk about the UI/UX challenges that are going to happen with these types of applications. Users shouldn't have to be distracted. So most of the users of this application are not blockchain or crypto people. They likely know nothing about gas costs. And it's important in terms of designing the UI, UX, and in fact, the services that you try and avoid using MetaMask, which we do. And so most of these transactions occur in the back end. We don't want users to have to worry about private keys or public keys. And in our system, each user does get a public and private key, but the private key is not visible to them, and it's transparent. The other sort of major issue is blockchain, especially the Ethereum blockchain, can be slow. In terms of how this is reflected in our architecture, we have our users sign raw transactions invisibly. So when they are submitting a transfer in the background, the user is effectively signing that transaction, and then it's submitted to our transaction manager, which uses a gas station network for processing. In terms of keys, transparent to the user, we assign every user a private public key pair. We store the private key pair in an Azure Key Vault. The user data is stored in the authentication service, and access to the private key is limited to our transaction manager. For lengthy response times, I guess with our designers, we did have some issues where, you can't wait for a loading indicator to say your transaction succeeded for a long period of time. So we use a lot of WebSockets in our application in terms of delivering these notifications and panels that explain what is happening. This is taking time to process. You'll receive a notification when things are done, etc. Synchronicity of blockchain transactions. Let me talk through that. So here the problem, we do provide a UI, but as I indicated, most of the transactions actually come through the ingester service. And the ingester transactions, which are coming from those ERP systems, it's important that they're processed synchronously, because if there may be dependent transactions. So for example, you can't create an invoice unless the purchase order has been created. And so if one of those fails, the whole batch can fail. And also, in terms of moving towards a public chain, we need to make sure that we retry transactions which may be required because of not enough gas, or the nonce being wrong, etc. So to fix this, we actually track every request through our API with a request ID. So every blockchain transaction can be traced back to an original request. The Kafka bus or the event-driven architecture allows our transaction manager service to retry those transactions and is responsible for sending out notifications and stopping the processing of a batch if the transaction has failed. I think, oops, sorry. Okay, yeah, sorry, next slide. Okay. So the other issue is privacy and transparency and security, especially with public chains. When we started this or when I started working on this in 2019, privacy solutions were very limited and just starting to be developed, like zero knowledge proofs, etc. Layer 2 technology barely existed. So things have changed since then. But there are stringent policies with respect to data privacy. So we need to make sure that nothing sensitive is being stored on the blockchain. And in fact, if you were to look at the blockchain data we store, it would likely be incomprehensible because it's primarily transaction hashes, or where important data is stored, it's encrypted. You would need the off-chain DB to code that. The private key, loss of a private key, I talked about that, we addressed that. And in terms of going to the public blockchain, our permissioning system has to be able to manage and ensure that any of our smart contract functions aren't exposed, and only people with the appropriate permissions can execute those. So yeah, really two approaches here. A conscious approach to making sure any transaction hashes are stored on the blockchain with permissioning, a very granular permissioning system, which determines which data can be seen by which users. And there's no worry about anyone losing their keys here because of the way we've set up the private key, public key storage. And in terms of going to in protecting our smart contracts on a public chain, we've extended our permissioning system to provide permission delegation to smart contracts. So this is a type of situation where you may have one contract calling another contract, but that whole chain of events was initiated by a user. Gas fees and costs. Gas fees are very expensive, as everyone knows right now on Ethereum. I see there's a question here. And it can make operating on a public blockchain very expensive. The other thing is that our smart contracts are somewhat more complex. While we do use a lot of Open Zeppelin standard contracts for the token-related stuff, for the entities, fundings, and the OKRs, we do have a more complicated smart contract structure. And so tracking that's forced us to really ensure that we're optimizing our code, the potential gas costs. And just to give you an idea, we have a sample data implementation that currently right now on Ethereum would cost around $250,000 over a year in gas costs. By moving to a layer 2 solution, we can cut those costs by 20,000. So that cost goes almost down to $5, which makes the operation of PFM very economical on a layer 2 solution. And the added advantage in terms of the layer 2 solution is having the security of the main Ethereum blockchain in terms of ensuring the validity of the data. Configuration, we're designing the app for global users, so we make a lot of usage of I18N in our interfaces, our UI interfaces, and we make sure that the metadata and labeling can be customized with configuration files. So basically, with the same code base, we can change labels so that they're appropriate to each use case, as well as language as well. And again, we use a modular design pattern so we can easily turn items on or off. And on the back end, when we set up an implementation, we can configure, the network it will use, whether Ethereum, mainnet, private Geth, or Polygon. So I went through quite a bit there. It looks like someone has asked for a question, but let me just wrap up. Web3 is challenging. There's a lot of things from a UX perspective that you need to factor into your designs. The gas costs are useful in the sense that they force you to think about computational efficiency and whether you're doing things in the best way possible. Yeah, one interesting thing, rapid innovation really requires us to keep abreast of changes. Yeah, as I indicated, I think when we started this in 2019, EY open sourced Nightfall, which is a zero knowledge proof system. I think at that time, the gas fees for running that were running at about $3,000. Now, in terms of innovation, those fees are down to mere dollars. So, and likewise with the layer 2 solutions. Now, as an Ethereum developer, you have a lot of different options you can look to for optimizing the security of the application and still gaining the security of that underlying Ethereum blockchain. So that's basically what I've summarized here. I should do a plug for EY blockchain. I'd be remiss if I didn't. But I would encourage anyone who's interested to visit blockchain at ey.com. We have a range of services and products, including supply chain products, which can be used by organizations. In fact, Peroni is currently shifting their supply chain to the service. We have a smart contract analyzer, which can analyze your smart contracts, and a blockchain explorer and visualizer. And if you live in the US, I believe there's even the ability to get your taxes, your crypto taxes worked out. So I encourage you to visit that. And we do have a large commitment to blockchain, public Ethereum. This year we announced we're going to be, the firm is going to be spending globally $100 million to fund blockchain and crypto asset research, engineering and services. We're continually evolving our smart contracts system, and we're contributing, actively contributing in the public domain. Our zero knowledge proof compiler, or Nightfall as it's commonly known. And this is the Bira Peroni service I mentioned. So yeah, that was sort of a high level overview. I hope it was informative, and please go ahead and ask any questions you may have. I'd be happy to answer them.
Alrighty, thank you, sir. That was awesome. Really, really valuable stuff there. So, yeah, this person's onto it. Before we move into questions, let's see some hand clap emojis. David just dropped some knowledge bombs for you there. Let's see a little bit of engagement there. I know we've seen a few kind of thumbs up on LinkedIn, which is awesome. So certainly want to open it up to questions now. If you do have any questions, please put them in the Ask a Question tab. Let's jump to our first question. It's a bit of a doozy for you here, David. It's from our other presenter, Dave, who's coming up in a little bit. Okay. So we got one for you here.
So, do you want me to read it out? Or
I was going to read it out now, and you can give the answer. So, Dave has asked, if a transaction has already been signed and the nonce was part of that transaction, how do you handle a transaction failing and keeping the next transaction working with the correct nonce?
Okay, so basically we use our Kafka message bus and our transactions manager to track those transactions. So if the transaction failed, our Kafka bus would send a notification to the relevant user that the transaction failed. We probably retry the transaction because our Kafka message bus or and our transaction manager service doesn't know that it may be errors, but we return, use the Kafka event-driven system to send back a notification to the user via live WebSockets or an email notification can be sent.
Nice one. Dave's probably there, like jotting down some notes there. Maybe you've helped him with a little problem. Look, we'll certainly open it up for another 10 to 15 seconds. Looks like we've got another question there. So we're done answering Dave's question. Jumping to a question from Owens. Nice to see you there. Owens has asked, how much does the future of blockchain technology depend on the increases of renewable energy sources? Yeah, great question there.
I don't think it really does. I mean, it's an interesting question, but I think if you look at Ethereum right now, for example, Ethereum is obviously conscious that proof of work is very energy intensive. Later this year, they'll be hopefully launching, and probably next year we'll have ETH2 in operation. And that's a proof of stake system which will significantly, reduce the energy required to verify and validate the transactions. Even with Bitcoin, you see a lot of negative comments in the press about how Bitcoin is highly energy intensive. But, I think if you look at some of these Bitcoin mining operations, they are making a conscious effort to use energy that would otherwise be wasted. I think I saw an article yesterday about a lot of people rushing to Texas to take advantage of gas that is just, burned in the air to run their computers. So incrementally, I don't think it's going to really be dependent. I think it's being addressed.
Mm-hmm. Nice one. Shout out to El Salvador officially mining their first Bitcoin using a volcano. That's awesome. That's what I get excited about. It's just crazy. Like, oh my God, we're using volcanoes to make digital money. It's fantastic. Look, we'll leave it open if we have any other questions. Probably, David, I want to ask you, mate, just kind of you throwing in your 2 cents. Obviously, you're talking about a lot of regulation in the crypto space. If you had a magic ball, where do you think this technology specifically, let's kind of pin it to the cryptocurrency world, where do you think it's going? If you had to, as I said, look at a magic ball and kind of forecast when you think there's going to be some big changes or big innovations, any thoughts on that at all?
Yeah, no, so I can tell you it's happening. It's unfortunately not happening in Canada. I recently worked on there's several big financial institutions in the US that are soon going to be able to take Bitcoin and Ethereum, and we'll start looking at, other transactions as well as tokenizing some of their existing financial assets. So there's a lot of activity in the US market right now. Almost zero in Canada. The only positive thing I saw yesterday with respect to Canada was Wealthsimple will soon allow you to be able to transfer crypto into their accounts. So I think that's a really positive development. Unfortunately, I think, the big banks in Canada are a bit slower off the mark and have a bit too much oligopoly power here. That's my personal opinion, not an EY opinion. So
just a little prefix there though. This is David talking, not EY. Yeah, totally, mate. Look, as an Aussie kind of, and I'm sure you said you lived in Asia too, the banking and insurance system here, it's a bit around the corner, you know what I mean? It's as in it's behind. There's a lot, lots of innovation happening. The user experience I find is really slow, and it's just not progressive in many ways. So yeah, totally agree with you there. Well, look, David, mate, really, really, really grateful for you stepping up and being part of the forum tonight. We're going to, obviously we're recording this. We'll post it to our YouTube channel. I'm sure there's going to be a lot of Very interested audience to kind of see that. So yeah, again, really, really grateful for your time. Best of luck in your successes and journeys at EY. And if you ever want to present again, mate, we'll be happy to have you back. No problems at all.
Okay, thank you very much.
Thank you,
And
sir.
encourage the audience to please reach out if they want to connect.
Yes, sir,
Yeah.
I will do.